I love math, the way the path goes on the graph, how it functions. Cause great discussion in the math class, shall put no textbook before the math class. Functions real radical and very graphical. That's the way it goes in the math class, some of the real.
Hey class, this is Mr. Ivan, and I'm going to be doing the solution video for the quiz of last week of January 2026. So this is for section 2.1 and 2.4. Okay, so first question is, they're asking you about this given polynomial, and they want to know what the degree is. So remember, the degree is the highest exponent, which happens to be 5. So this is pretty easy. Next thing, they want you to find the leading coefficient. So when you want to find the leading coefficient, you want to think about what the term is with the highest exponent, which in this case is this term right here. And you want to look at the number that's right in front of it, which happens to be -3. So -3 is my leading coefficient. Okay. Now they want us to sketch a graph of this. So I want to extract as much information as I can from this. One piece of information the students were not really utilizing is the y-intercept. So if I want to use the y-intercept in this case, let's just say it's right here. Let's just say 7 happens to be right here on the y-axis. And I know that my y-intercept means that my function eventually has to cross that point. So I'm just going to mark it right there. Next, I want to use the degree of this. So if you notice, my degree is 5, which is an odd number. So if we remember in class, we know that odd behaviors, end behaviors, means that I start off either on the left-hand side and crash on the right, or I start down here on the left-hand side and eventually I grow up. So which one of these is it then? I know that it happens to be this one. The reason I know this is because my leading coefficient is negative. So when I sketch this, I'm going to rise up on the left-hand side and eventually I crash on the right-hand side. But now I got to figure out what happens in between here. So the next thing I want to do is use my information about number of turns. So if you guys remember in class, we learned that the number of terms is equal to degree minus 1. And I happen to know what my degree is. We just found out that it's 5. So I have 5 minus 1 equals 4. So I have 4 turns. So when I go ahead and sketch this, I can go ahead and actually do 4 rough turns. Maybe 1, 2, 3, 4. It does not have to be perfect. The idea is that you do 4 turns and the end behaviors start off on the left-hand side, so going up, and the right-hand side crashes down. So this is how I sketch it. All right, next we have simplifying. So notice that there is a negative sign here in front of the parentheses. Some students decided to multiply this. So you want to keep in mind, whenever you have a parentheses and there's a negative right in front of it, you want to think about distributing this. So when I do the first term, 6x to the power of 4, I want to find a term that's very similar to it. This one right here is the only one I can find. So if it helps, maybe you can think of distributing this negative. So I'm actually going to subtract in this case 2x to the power of 4. And the next thing I want to do is I want to bring down my next term, -3x cubed, and I'm going to subtract it by 7x cubed. Same idea, distribute. Next thing I want to do is bring down my next term, which is 5x squared, and I'm actually going to add it by x squared because I have a negative times a negative. And then lastly, I have -2x subtract 4x. Combining like terms, I end up getting 4x to the power of 4 minus 10x cubed plus 6x squared minus 6x. And there's nothing else for me to combine, so this is my final answer. Okay, next up we have box method. So they want us to multiply polynomials. So in class, we learned that we can use the box method when we're trying to multiply polynomials. In this case, I'm going to set up my 3x2 box because I'm multiplying a binomial with a trinomial. So I'm going to write down 2x minus 3 on one side, and I'm going to write down the next term, x squared plus 4x minus 5. Inside here is the results of multiplying the sides. So now I have 2x cubed, I have 8x squared minus 10x, negative 3x squared, negative 12x, positive 15. Now I want to combine like terms. Combine these and combine these. Final answer happens to be 2x cubed plus 5x squared negative 22x plus 15. There's nothing else for me to combine, so this is my final answer. And that's it. Multiplying polynomials. Last question, they want us to divide. So in class, we learned two methods, synthetic division and reverse box method. I'm going to show you both. So let me show you synthetic division first. So synthetic division, so the number that goes outside here is actually the result of taking the divisor and setting it equal to 0. So in this case, I have x plus 2, which means that x equals negative 2. And that's the number I put outside here. Now, to figure out the numbers that go inside the synthetic division bar, I have to use the coefficients of my dividends. So in this case, I'm going to use 2, 5, negative 3, and negative 4. First things first, I bring down the first number, which is 2. Multiply diagonal, gives me negative 4. Add these two, gives me 1. Multiply diagonal again, gives me negative 2. Add gives me negative 5. Multiply gives me 10. Add them together gets me 6. So once you get to the last number, that happens to be your remainder. So before I write down the final answer, I'm going to write down the rest of everything. So if it helps, maybe I can write down the entire problem. So the entire problem is 2x cubed plus 5x squared minus 3x minus 4. This is being divided by x plus 2. And I'm multiplying that. My final answer is 2x squared plus x minus 5 plus 6 over x plus 2. This is my answer. And some of you prefer maybe writing it this way. If I multiply both sides by x plus 2, I end up getting this. Multiplying both sides by x plus 2 gives me now x plus 2 on this side. And I have 2x squared plus x minus 5 plus remainder 6. Both of these answers are the same. It really depends on what you prefer. The top or the bottom. Alright, now I'm going to do synthetic division. So when you're doing synthetic division, box method. So when you're doing box method, on top, you put the divisor, which happens to be x plus 2. So I put x plus 2 as my divisor. And the very first entry is the first term of the dividends, which happens to be 2x cubed. So I have 2x cubed inside here. This means that this has to be 2x squared, which means that this is 4x squared. Now I have to figure out what goes on the diagonal. To figure that out, I look at my second term, which happens to be 5x squared. So that means this it has to be x squared, because they add up together to get 5x squared. So that means this has to be x, which means this is 2x. Same idea. I want to figure out what this diagonal is. It has to add up to negative 3x, which means that this is negative 5x, which means that this is negative 5, which means that this is negative 10. Notice that my last number does not match this one, right? But to figure out what my remainder is, I have to take this last number, add it to r, and it equals the last number from my dividends, which is negative 4. Adding both sides by 10 gives me r equals 6. So my remainder is actually 6. So my final answer is all of this on the side, 2x squared plus x minus 5 plus remainder over divisor. And this is my answer. And if you notice, it's the exact same thing from synthetic division. Alright, I hope this video was helpful, and I'll see you guys in class. Bye.
Are you tired of having the same old cereal every day with boring old milk and boring old cereal? Well, do I have the right thing for you? We got the mathematical cereal, 100% pure math milk with 100% pure math cereal.